Next, we come to fiber optic cabling, which is also called 10-base-FL. This type of cabling is not commonly used to connect to individual PCs. However, it is the standard way to connect networking hardware, such as concentrators and switches. The reason fiber is used in this way is because it can carry much larger amounts of bandwidth than coax or twisted pair, and, as we'll learn a little later on, the bandwidth requirements between concentrators are much higher than the requirements for individual computers. The two greatest advantages of fiber optic cabling are bandwidth and distance. It's designed to support bandwidths that range up to hundreds of gigabits per second. Fiber can connect devices at distances exceeding 100 kilometers. And although these two things make fiber attractive, it also makes it expensive. When installing network cabling, users must balance capabilities against cost. This is why most environments today use a mixture of twisted pair and fiber. Fiber is available in two major varieties, called multimode and single mode. Multimode fiber is less expensive and is good for distances around 5 kilometers. Single mode is more expensive and can support distances between devices of over 100 kilometers. Both types support high bandwidth capabilities. Another advantage of fiber cabling is, since it uses light pulses to send data, fiber is not affected by electronic noise. Fiber cabling is also resistant to eavesdropping. As we see, fiber offers the best capabilities of any media type. The only drawback is the price. However, users are starting to realize that if they install fiber in their network once, they might never need to replace it as bandwidth increases. This is not true with twisted pair. So in the long run, fiber may end up being the least expensive option.